Can everybody hear me now? Oh, awesome. Okay. Well, let's get this show on the road then. So this week we started doing the chain rule, which I think is 3.3. It might have been 3.4. I think it's 3.3 though. And then we did the product and quotient rules for taking derivatives. And again, like last week, this is just like a lot of practicing and practicing and practicing to see if you can get it right. Which is, not exactly the easiest thing in the world and pretty time consuming, but we're going to go ahead and do some practice problems and see how you guys are feeling about this material. So let's start in section 3.3. One sec, let me check to make sure I'm recording. I am recording, that's good. Okay. So let's start with problem 4, which looks like this. And this is page 155, by the way. And then we'll also do problem 8. Okay. So the trick with the chain rule is to find a function within a function, right? So generally, I say there are like 2 ways to look at this. You can start from like the inside out. So you can say that there's a function in this parentheses here, and it's got another function attached to it. Or you can kind of work from the outside in, saying, I know I have a power here inside the parentheses, know what's inside the parentheses. And that may kind of make more sense when we start looking at like larger like pieces that we're going to be like digesting as part of the chain rule. But basically what you're doing is looking for a function within a function. In that case, the function here, the first function is going to be, I'm just going to say it's u. Is that what they use in the book? No, no, they use f and g in the book. That's what we're going to use then. So, in the rule, it says that f of g of x. So g is our inside function, if I can spell, and f is our outside function. Is equal to, and this is prime, is equal to f prime g of x times g prime of x. So this is kind of the rule that we're going to be using as we solve this problem. So basically what we need to do is identify which is f and which is g. And this is kind of the same process we're going to be using for the stuff that's in 3.3 and the stuff that's in 3.4, because it's a different formula that we're going to use, but there's still 2 functions involved. So g is our inside function, so it's going to actually be g of q here. So g of q is equal to q squared plus 1. And then the first thing I do is I just say, so if g of q is equal to that, then g prime of q is equal to 2q. So I have both of these written down right away. And then what I'm going to do is do the same thing for f. So f of g is going to be equal to, so if I'm going to say that this is g, then that is g to the 4th, right? So if I take this whole thing and I say that that is just equal to the variable g, then I can put g in here, and this is something I can work with. I can take a derivative of that. So f prime of g is equal to 4g to the 3rd, using our rules from section 3.1, which is the power rules. So now I have f prime, g, and g prime. So what I'm going to do is I'm going to smash it all together. I am going to say f prime of g is 4g to the 3. And here I have g, which is q squared plus 1. And this is all going to be times g prime, which is 2q. So my final answer is just going to be this whole thing multiplied together. So that's going to be 8q times q squared plus 1 to the 3rd. Does that kind of make sense, how this whole process went down? I'm getting nothing in the chat. You guys are quiet today. Awesome. Cool. So let's do the same thing with question 8. So first things first. Oh, I'm glad. First things first is I always write down what the functions are. Yeah. No, this is something that you really have to take step by step. And I still, like, if I hit a problem and I need to take a chain, like use the chain rule to solve it, I will still write down every step along the way, because then it's easier to go back and if I like messed up, to find where I messed up. So first things first with this, we're going to write this in a way that is easier to understand. I hate looking at this whole square root sign, so I'm going to write this as y is equal to s cubed plus 1 to the 1/2, which is how we were solving things with square roots using the power rule. And then first thing I'm going to do is identify g, which is going to be my inside function. So that's going to be s cubed plus 1. And then I'm going to go ahead and find g prime right away, which will be 3s squared. Then I want to look at my outside function, which is going to be this, and this is g. So f is going to be equal to g to the half, and f prime is going to be equal to 1/2 g to the negative 1/2. So I'm going to subtract 1 when I take that derivative using the power rule. And then it's just a matter of putting it all in where it needs to go. Using the same equation up here, f prime of g. So here is that, f prime of g, which is s cubed plus 1, times g prime. So I'm going to write it all out in like a simplified way. I'm going to have 3s squared over 2s cubed plus 1 to the half. So basically, this is the exact same thing as this. It's just simplified and written in a more condensed manner, because this is going to be on my numerator, and this is negative, so I can just bring it down to the denominator. But both of these answers are considered correct. It's just that you might find this one as an answer on a multiple choice test. But both of them are right. Thoughts, comments, concerns? Taking that as a no. Let's give one a try. So I am going to make you guys do this one in the chat. I think we're going to do number 12. Yeah, let's do number 12. All right, so this is y is equal to 5e to the 5t plus 1. We always are going to put the g back in, so the original inside function is in the right terms. I can show you like this time around, but if we have like g is equal to s cubed plus 1, and we're doing this whole thing, and we have 1/2 g to the negative 1/2, and then it's times 3s squared, then we have two unknowns. So we have g here and we have s here, and we know what g is in terms of s. And so it's best to just have things just be one variable. Is that the question you were asking? Awesome. There we go. Okay. So What is going to be my G? And what is going to be my F? So the first thing I would do is look for a function in this. So somebody name me any function that's in this shindig. Okay, so we have a suggestion that E is going to, or G is going to equal E to the 5t plus 1. Okay, let's try that. What is G prime? Well, it's not going to be the same because if we, for instance, have e to the 12x, if we take the derivative of that, it's going to be 12e to the 12x, right? So if it's not just a variable up here, then we do have some changes happening when we're taking derivatives with the e function. So G prime is not going to just be e to the 5t plus 1. Any other suggestions? Okay, so you're saying that this is going to be G prime? That's a really good suggestion because you're remembering to take that 5 down, but what are we doing about this plus 1 here? Does it though? Okay, so basically we are gonna use the chain rule here. We're not going to just use the power rule. I'm not sure what you say it cancels due to the power rule. Because like when we're looking at something that's like up here, this is like a whole entity. So consider if I had like e to the 12x. So if I were to take that derivative, it's going to be 12e to the 12x. But if I had e to the 12x plus 14, I can't just make that e to the 12x plus 14 because there's a difference here between like having an addition in this shindig. Another way of explaining it maybe is saying something like this. Let's try to simplify this in terms of, okay, so in terms of like rules of E, if we have like e to the 5t times e to the 1, then that could be equal to e to the 5t plus 1, because that's just kind of how like multiplying powers works, right? I think that's how multiplying powers works. I hope it is because I just said it. And so taking the derivative of this function is different than taking the derivative of this function. What I'm trying to kind of get at here is that it's a little bit of a struggle and you're forced to like make some assumptions if you make that your G. So picking this as G is not what I would do, because then you're basically still in the same boat that you were when you started to solve the problem. What I would do is I would say G is equal to 5t plus 1, and F is equal to 5e to the G. Because this way I can say that F prime is 5e to the G, and g prime is equal to 5. Does that make sense why I did that? I'm kind of looking for functions within functions here. And the one that I decided that I wanted to split apart was actually this function that's up here, and then the function e to the blank. So I have this e to the blank function, and then I have this 5t plus 1 function. And those are the ones that I'm breaking up so that I can analyze it using the chain rule. So that being said, this is going to turn out to be 5, that's wrong. I don't know why I did that. 5e to the 5t plus 1 times 5, or 25e to the 5t plus 1. Does that make sense? Oops. Awesome. One thing about like these problems in specific, like as you get like further on in this like class, it's gonna like you're gonna get some more complicated stuff. But one thing about like this section that's really nice is that like they generally aren't going to give you something that's like super long and messed up. So if we were to have said that g is equal to e to the 5t plus 1, and we did say mistakenly that g prime is equal to 5e to the 5t plus 1, then we would have ended up with a much longer answer here. It would have been 5. Actually, I don't know how that would work. But yeah, more complicated answer. Okay. Let's do another one. Let's do 18. Do you guys want to give this one a try? I'm gonna have you guys give this one a try. I'm gonna make you guys do it. Okay. So now we have our function that's f of x. I'm gonna say the inside is still gonna be g of x, but I'm gonna call the outside h of x just because I don't like confusion. So I'm going to say that h of g of x prime is equal to h prime g times g prime. Okay, so what is h and what is g? Just like a tip, I tend to just automatically look at anything in parentheses. And if there's a natural log in front of it or a power up here, this stuff inside the parentheses is going to be my g, almost hands down. So parentheses are a really good indicator of trying to like track down which function is your inside function. So in this case, g is going to be 1 minus e to the negative x, and g prime is going to be, so it's -1 times negative e, so that'll be e to the negative x. So h is equal to ln g, and h prime is equal to 1 over g. So now we can put this all together. We can say that f prime is equal to 1 over 1 minus e to the negative x times e to the negative x. And I e to the negative x over 1. So you can just yeah, there's your answer. All right, do you guys want to do a couple more from this section, or do you guys want to move on to the product rule and quotient rule? All right, let's do one more. Like I said, if you're struggling with these rules, number one is to just practice, and number two is to write everything down. I've been trying to color code them so that you can kind of see where everything goes, but like the more you write down, the more you can just kind of like understand like what's going on. Okay, so let's do number 20, and that looks like f of x is equal to ln x. Oops. Yeah, I mean, like, I remember, like when I take exams, I take like 5 pieces of scratch paper with me, like if I'm doing it like online, because I just like I write everything down so I can come back and look at it if like I'm having an issue like later on in the problem. And so it's really useful for longer problems, but especially longer problems. But when you're learning this kind of stuff, it is also very handy just to like have like a written record of exactly what you were thinking at what time. All right, so what is G? All right, exactly. Stuff in the parentheses. So G prime is going to be equal to 1 over x. I don't know why I put that in parentheses, but I did, I guess. And I guess it's not wrong. Okay, so that would make h equal to g cubed and h prime equal to 3g squared. So we put it together. We say that this is 3g squared, where g is equal to ln x times 1 over x. So my final problem, or my final answer looks like this: 3 ln x squared over x. All right, let's move on to 3.4. Okay, so this is the product rule and the quotient rule, and these rules are pretty similar. And like with all of these rules, the best solution is to memorize them, because there's no like tips or tricks that make any of this like more just like why exactly does this work sort of thing. Like just memorize these rules and you will be golden. So let's start with problem 4. And this is 3.4 on page 160. So problem 4 looks like this: f of x is equal to x e to the x. And then we're also going to do problem 8. So first things first here, recognize which one is function 1, which one is function 2. You're always going to have 2 functions. In this case, instead of f and g, I'm going to call them g and h again. And it doesn't matter really which one is which, but the difference is that both of these functions will be functions of x, because they're 2 distinct functions as apart from functions within functions, and that's why you solve it differently than you do with a chain rule. So I can pick 2 g of x's. Which one do you guys want to pick for g of x? So we have 2 functions here. We have x, f of x is x, and then e to the x, exactly. So we're going to just say g of x is e to the x, which would make h of x, x. So h prime is equal to 1, and g prime is equal to e to the x. So the way that this works is we're going to have, use a different color, f prime is equal to g prime h times h prime g, or not times, excuse me, plus h prime g. This is an addition. So g prime times h prime times g. So we're not taking any functions of other functions. This is not g prime of h or anything like that. This is different from the chain rule. Two distinct functions, both of them of x. So then let's just put this in where it needs to go. G prime is going to be e to the x times h, which is x, plus h prime, which is 1, times g, which is e to the x. So our final product is going to be x e to the x plus e to the x. G prime h prime g. Yep, I'm glad to help, guys. This can get really, really dense really, really fast, and I think the book sometimes makes it a little difficult because it gets into like the nitty-gritty of it, but this is all you need to do to solve the problem. Figure out which two functions you're working with, and then work with them. So let's do this one. Here we have functions. I'm going to call them f and g now, or f of t, and then I'm going to have an f prime of t, and I'm going to have a g of t and g prime of t. The reason I'm writing these out explicitly of t is just because I want to reiterate the fact that these are going to be both functions of t. So I'm going to pick whichever one I want for f. In this case, it's going to be t squared plus 3. So that's this chunk. And the derivative of that is going to be 2t. And then I'm going to look at the other one, which is going to be e to the t and e to the t. So f prime g plus g prime f is kind of like the formula that I'm going to be going with. So f prime, 2 to the t, times g, e to the t, plus g prime, e to the t, times f, which is t squared plus 3. So when push comes to shove, my answer is going to be 2t e to the t plus e to the t times 2. Oh, that's wrong. T squared plus 3. And that's my answer. Thoughts, comments, concerns? Okay, so there's the product rule. Let's try one with the quotient rule. Yep, it is just memorization. You just got to know these rules. Write the rules out. Just keep writing them. That's how I memorize things, is I just write them over and over and over again. But do whatever, make a Quizlet, just do whatever works for you. So yeah, let's do problem 22. F of x is equal to x over e to the x. And then we'll do 24, which is w is equal to 3z over 1 plus 2z. Okay. So for the first one, what should my first function be? Now it does matter what order you put them in. I'm going to write out the thing. So this is going to be, initially, I'm not going to confuse you, so I'm going to do it a little differently. I'm going to say that h is equal to x, so it's h over g prime is equal to h prime g minus g prime h, I'm pretty sure. but I'm going to check. Yes. So h prime g minus g prime h over g squared. In this case, it's very important, like in the book they have it written as f and g, but I have an f right there, so I didn't want to like repeat the f in case that got confusing. But in this case, there is an h and it is on top, and there is a g and it is on bottom. And so you could write it like this, but you'd have to switch all of these, meaning it's g prime times h minus h prime times g, because you have a minus sign there, so that matters, and then it's over h squared now, because h is in the bottom. So it does matter which function you pick as this one, because they're not interchangeable, like they kind of are in the other one, in the product rule. So I'm going to say h is equal to x, because h is on top, and g is going to be equal to e to the x, g prime is equal to e to the x, and h prime is equal to 1. So I have h prime times g, 1 times e to the x, minus g prime e to the x times h x, all over g, which is e to the x squared. Okay, so then I'm going to simplify this. So it's e to the x minus x e to the x over e to the 2x. Okay. Yeah, you can. You could say this is e to the x minus, or e to the x times 1 minus x, so factor it out over the top, and then say this is e to the x times e to the x, I'm here on the bottom, because it's e to the x squared. Take those out, so it'll be 1 minus x over e to the x. Good call. You can definitely do that. Okie dokies. Let's do this one. So f is going to be, I'm going to say f is on top here, so that's 3z. So this is f of z. F prime of z is equal to 3. So my g is going to be what is here on the bottom. G is equal to 1 plus 2z. G prime is equal to 2. Then I'm going to put it all together. I'm going to say that, here it's going to be f, not h, I don't know why I wrote h, f over g is equal to f prime g minus g prime f over g squared. And I just like, I'll write this out, and I write out all of this to this day. All of this gets written out when I'm solving a problem. So skipping steps is much harder than you think, and doing this in your head is much harder than you think. So just write it all down. So this is 3 times g minus, and then this is 3z. Sorry, switching colors is time consuming. So this is going to be 1 plus 2z, and that's a minus, and that's going to be 2. So I have f prime times g, and then g prime times f, all over g squared. So that's 1, I was looking at 1 plus 2z squared. So we can simplify this all down. It becomes 3, 1 plus 2z minus 6z over 1 plus 2z squared. You can distribute this. I'm sorry, I'm kind of working up. You can distribute that 3 if you want to, and make this 3 plus 6z minus 6z. over 1 plus 2z squared. And then this turns into 3. These are going to cancel. Plus 6z and minus 6z. Or 1 plus 2z. And there's your answer. Sorry, this is where the chat box is, because I have the chat box open, but it takes up a ton of space. So you can kind of see how I work in like this like circular kind of formation, because I have to keep moving the chat box. But does that make sense to everybody, despite the fact that it's a little disorganized in this board right now? Awesome. All right. Let's do a couple problems from section 3.5. Like solve a couple problems. And then there was an exercise I kind of did last semester that worked pretty well, where we just talked about we just looked at problems and we didn't solve them. We were just trying to figure out, would we use the chain rule, the product rule, the quotient rule, what would we do there? So let's do that after we do a couple problems from 3.5. Okay. So this is back into the periodic functions, and the reason we're kind of back in this section after last week is that we wanted to introduce them last week so you guys knew how to take their derivatives, but there were some problems in this function or in this chapter that included chain rule and product quotient rule type solutions. So we're just going to kind of do a couple here just to, I don't know, test the water, see how it's going. Let's do number 10. Let's do 14. And let's do 18. So number 10 is this. $14. And 18. All right, ideas for number 10. What kind of a rule are we going to be using? Product rule. What makes you say that? Two functions. All right. My question is, where are the two functions? If you were going to solve this like a product rule, what would your first function be? And what would your second function be? Okay. Yeah, I believe Lloyd's got it. So your second function is going to be 4 cos, but you need to have cos of something, because cos on its own doesn't mean anything. It has to be cos of a variable or cos of a number or cos of something. So cosine on just these 3 letters has no meaning in terms of mathematical anything, because it needs to be the cosine of something. So the question is, what is it the cosine of? And in this case, it's the cosine of f. Because remember, if we were doing this in terms of product rule, we would have both f of t and we would have g of t, because these two need to be the same for the product rule. But in this case, it's g of f is the function, because this is for cos f. Does that make sense why we're going to be using the chain? Awesome. Okay. Next, the question is which function is on the inside and which function is on the outside. In this case, we've labeled them so that it's opposite. So I'm going to, what we usually do, and consistency really does help when we're solving these types of problems. So I'm going to switch it. So this is going to be F, and this is going to be, no, wait, actually, that's just literally what it was. I'm a doofus. This is going to be G because it's the inside one, and this is going to be F because it's the outside one. So G prime is going to equal to T, and F prime, what is F prime going to be? -4 sine G, exactly. We have to remember there's a negative sign because we're going from cosine to sine. So we're going to put this all together, and what it's going to look like is F prime of G times G prime. Does that apply in the reverse? Are you talking about the negative? Okay, so it's kind of messed up how, yeah. So if you take sine of x, you take the derivative of that, it's going to be cos x. But if you take the derivative of cos x, it's negative sine x. So the negative only happens when you're going from cos x to sine. Which is, there's a reason for it somewhere. I just never have really looked up the reason. But the negative sign only gets incurred when you're taking a derivative of cosine. Too. Yeah, I guess. I just kind of accepted it, so I'm assuming it is one of the accepted rules. There's a reason for it somewhere, but I don't know what that reason is, and I can't tell you right now. I can find out, probably. But yeah, so that's where the negative sign comes from. And that's another reason why it's handy to write all of this down, because if you are missing, like if you realize like partway through that you maybe forgot, then you can go back and check to make sure that your negative sign got put in. Okie dokies, so here's -4 sine t squared times 2t. And that means that W prime is going to equal -8t sine t squared. And that's our answer. Ta-da. What about this one? Number 14. Chain rule. What is our internal function? So our external function is going to be cos g, and our internal function is going to be for theta. Is that what you said? All right. So that means that f prime is going to be negative sine g. G prime is going to be 4. That means that when we're going to put this together, not negative. I'm taking a derivative of cosine and going to sine. Yeah, that's good. Always question, just make sure you know what's up. Okay, so that'll be negative sine g 4 theta times 4. 4 -4 sine. I don't know. Why did I write G there? That's ridiculous. Sorry. I'm so sorry. I don't know why the G ended up there. So the G is the 4 theta. Ignore that pile of pink goop. And so it's sine 4 theta. So this is our answer. Now there is another way of getting to this. Last week we learned about a rule essentially that would just pull the 4 out when we took the derivative. And we said that we could think about it in like one step. We pull the 4 out, we put it out front, we take the derivative, and we end up with -4 sine 4 theta. And the reason that we were able to do that rule last week was because the chain rule exists. It's just that this function in the middle is simple enough that we think that we can do it in our heads, which we can. We can do it in our heads. But I would highly encourage you to not do it in your head if there's a complicated function inside. Does that make sense? Awesome. Let's do number 18 then. All right, so for number 18, what type of rule do you think we're going to be using? Product rule. What is our first function? Okay, and our second one is just going to be cos theta then. So G prime is equal to negative sine theta. And we know that this is going to be H prime G plus G prime H. That's our equation. So we have 3 theta squared times cos theta plus theta cubed times negative sine theta. So we can just kind of like simplify this all out. So it's 3 theta squared cos theta plus theta or minus theta cubed sine theta. And that's basically just our answer. You could factor some stuff out if you wanted to, but that's how I'd leave it. So yeah, that's basically the gist of this whole thing that we're doing this week, is figuring out how exactly to take the derivatives based upon rules that we have to memorize. So I'm going to write down a couple things. And I'm going to have you guys think about how we would solve them. Okay. So for this first one, what rule do you think we're going to use? Product rule. Exactly. Because we have these two distinct functions, and they're both functions of t. What about for b? Chain rule. Because we have a function here on the inside, and like I said, parentheses. Like here, you've got parentheses, but like once you look at it a little bit closer, not going to be chain rule. Here, you look at parentheses, you see an inside function, and then an outside function. And so you're going to be looking at solving using the chain rule. C, quotient rule, probably the easiest to diagnose. Thanks. The division. All right, and what about D? Chain rule, exactly. Because we've got this function up here, and we've got this big function down here. This function up here, and the bigger function. All right, you guys are great at that. Wow. How would I solve a problem that looked like this? Where would I start here? Can I use more than one rule in a single function? You absolutely can. The thing about these addition things is that it makes it easy because f prime of x is going to be the derivative of this plus the derivative of this plus the derivative of this. So what I can do is take the derivative of all of these individually and then make that into f prime. So that's how we're going to solve this. Do you want to start with the easiest one first? Which is going to be this one. So this is just take the derivative of x squared is going to be 2x. What about this next one? E to the x cubed. What rule are we going to use here? Chain rule, exactly. Because we have our x cubed up here and we have our e here. So g is equal to x cubed. F is equal to e to the g. F prime, e to the g. G prime, 3x. So the derivative of this is going to be 3x times e to the x cubed squared. Yes, thank you. 3x squared. So that squared is going to be there. So that's what this is going to look like. So it'll be 3x squared e to the x cubed. All right. And so for this one, we've got a big chunk of thing going on. What is the first thing that you guys see about this function? Actually, I'm going to switch up this function a little bit. Yeah. This. Yeah. Essentially, it is there's three functions that we have to deal with here. What rules are we going to be using to solve this? This is really grody looking. I'm not even sure if something would look like this on a test. This is about as bad as it gets in terms of like what you guys are going to be working with. So, yep, we're going to use the chain rule. And what other rule are we going to use? Product rule, exactly. So here is the thing we're going to use the chain rule on. And we're going to use the product rule on this whole shenanigan. So where I would start is actually with the product rule. I would sit down and I would say that my f is going to be, so f of x is equal to x to the fourth. And then f prime of x is equal to 4x cubed. Just so that I like have that in my back pocket. I know where I'm going. Because if I look at this generally, what I need to do to take the whole derivative is the product rule. So then I need to sit down and look at g. So my g is going to be sine of e to the x. And I know I can't solve this using regular rules. So that's when I'm going to move on to the chain rule. I'm going to say that h is equal to sine, what letter should I use? I don't know. Sine z. And then I'm going to say that z is equal to e to the x. So z prime is equal to e to the x, and h prime is equal to cos z. Is everybody following me on how I'm doing this? Awesome. So I have all of this information. I just need to put it together. I'm going to write out the rule beforehand just so that I know where, like, just I have a guideline of where I'm going. So I'm going to have h prime of z times z prime. And the way that I know which one is which is that I'm going to have my internal function still like be internally here, and z is my internal function. And then I'm going to have it multiplied by the derivative of the internal function and the derivative of my external function out here. So it's just like getting familiar with the formulas enough that you're comfortable switching the variables around, which is a point that you guys will get to. So I'm going to put this all together, and I'm going to say that g prime of x is equal to, I'm going to say that it is going to be cos of e to the x times e to the x. So now I have all the information I need to solve this using my product rule. I have f prime, I have g, and thanks to the chain rule, I have g prime. So I'm going to put it all together. I have f prime for product rule, f prime g plus g prime f. So 4x cubed times sine of e to the x plus g prime, which is e to the x cos e to the x times f, x to the 4. So this is all going to simplify down into a very nasty looking function, which is going to be 4x cubed sine e to the x plus e to the x, x to the 4, cos e to the x. It's grody, but that is what the derivative of this shindig is. So we could just put it in this whole thing. And that is our answer. So we started with this function up here. And we broke it apart into like what we could add. So we started here, we can add all of these derivatives. So we took the derivative of this to get this, took the derivative of this, and then we took the derivative of this last one. And that's what turned out to be the grody one, but that is how you find a derivative of a big long monster like that. Thoughts, comments, concerns? I'm hearing nothing. Are there any questions? All right. Well, if you guys do have any questions, please feel free to email me or let me know, and we can talk about them next week. But I guess if nobody else has any questions, then we can say goodnight. I should post the recording tonight, probably. Did I not post the recording last week? Oh my gosh. Okay, I'm so sorry. Things are a little hectic with work. I will get on posting recordings immediately afterward, so that they get up there. And sometimes I forget to make an announcement, but you guys can always check my YouTube channel. Oh, this sounds like a really bad plug. Please check out my YouTube channel, like and subscribe. But basically, sometimes I post it on the YouTube channel and forget to make an announcement. So there is stuff on the YouTube channel that may or may not have been announced, but I don't think I posted it last week. So I will do that. I will post both of them, and I will do it right now as soon as my video is done rendering. So that is what I will do. Thank you guys for reminding me.